Welcome to Methamphetamine. Today we're gonna do two sessions question. The first one is tell me to integrate square root of tangent x. The number 2, tell me to integrate square root of x over 1 plus x squared. Since we have the two sessions, and session 1 and session 2, so session 2 may about this, right? Square root of tangent x. So here is the deal. So the first one, square root of tangent x, is kind of a tough integral. And first, we let our u is equal to square root of tangent x, like that. Let me just put the lip of the pen on here. Okay. The u is equal to tangent x. I'm not going to differentiate both sides yet because it will be kind of crazy. I would like to square both sides to get u squared is equal to tangent x. So here we can just differentiate both sides, get 2u du is equal to derivative of tangent x is secant square x dx. Okay, what is our dx right now? Dx is equal to 2u du over secant square x. I want in terms of tangent x. So it's become 1 plus tangent square x. So you can just square both sides. You get tangent square x is equal to u power 4, right? So let me just write it as 2u du over 1 plus u power 4. So you will get the integral. The original is u times 2u. The original is u and then times 2u over 1 plus u power 4 du. Let me just write as u power 4 plus u plus 1. I like to write the variable at first. It's my hobbies. And if you like, you can write 1 first, up to you. Let me just write u power 4 first, plus 1, and then let me put a 2. This 2 is really important here. You will see why. 2u squared du. And how can we integrate it though? Since you see the denominator is u power 4 plus 1, it will be kinda torture if you want to factor it. Right, u power 4. So since the power is too high, let me just divide by u squared on one side. Just both the numerator and denominator, you get 2 over u power of 2 plus 1 over u squared. Let me just factor it as 1 over u and then square that du. Since we don't have enough space, we can just put it here. Here I'm going to complete the square, like here. U squared plus 1 over u square. I would like to get 2ab here. Let me just add 2 times u, this I'll be, we take a square here, right? 2 times u times 1 over u, and then don't forget to minus this. Over you get 2 here. So you get u squared plus 1 over u squared is equal to this. And then this over here, you just complete the square. You just get u plus 1 over u squared minus 2 here. And the same thing, you can just, first we do add and then just minus. But we can also do minus and then add. Minus 2 and then add 2 here. So you also get u minus 1 over u squared plus 2, like that. So we can get we can split to 2 integrals right now, because since we have the same denominator, this is u plus 1 over u squared minus 2 du, and then plus the integral of u minus 1 over u squared plus 2 du. Here's the fun part. What's the derivative of u plus 1 over u. If we know the derivative, you can just let u is equal to that. We want something on the bottom of the on this numerator. We want something to be our if we let w is equal to this on the function, we need something here. So differentiate, it should be du of u plus 1 over u. You will get 1, and then do this, you get negative 1 over u squared, like that. So another thing, du of u minus 1 over u, you will get 1 and then plus 1 over u squared. So you see the original, we get 2 here. This plus that, this and this, they are cancelled. They are cancelled. Negative 1 over u squared plus 1 over u squared, they cancel each other out. So you can get the original 2 here. We already know the derivative of this is equal to u plus 1 over u. So let me just put this on the top. 1 minus 1 over u squared, and then this is 1 plus 1 over u squared. So we can just use our u sub right now. We get an original red, and then use our u sub. Most people like to use the w or u or t equal to this. And this time we can use this trick. Put the integral inside. Put this integral, you just get this, right? Because the derivative of u plus 1 over u is this. So integrate this, you can put it inside this. U plus 1 over u, and then u squared plus 1 over, not u squared. This integral is pretty tough, yes, really tough. This is just u plus 1 over u square, and here I'm going to write as root 2 square minus root 2 square, and then plus this is 1 over, because we know the derivative of this is that, so we can put it inside. You get u minus 1 over u square plus root 2 square, and d our u minus 1 over u. Here is the deal. We can first, this is the most common one. We don't have enough space, so let me erase this, the complete square part. Complete square part. Here's the deal. Here is the deal right now. Whenever you are going to integrate 1 over something x squared plus a squared dx, we only get one formula, I think. This is just the most common one. 1 over a times inverse tangent of x over a plus c. The second one is kinda crazy. The integral of x squared minus a squared dx. We have 3 versions of it. The first one, just don't care. You just use the partial fraction. Partial fraction, you get 1 over 2a times L1 absolute value of x plus a over. But this time is x squared minus. The integral of 1 over a squared minus x squared is this. But we switch the sign, we need a negative. And then put the negative inside, you just need to switch the order. X minus a over x plus a plus c. This is just another domain. We don't anything except 0. The inside can be 0, or any numbers are acceptable inside. The second one is negative, because the integral of 1 over a squared minus x squared is positive. So switch the order, you get negative 1 over a inverse hyperbolic tangent of x over a plus c. And another one is negative 1 over a. I leave a blank here, you will see why. Negative 1 over a times inverse cotangent inverse quotient of x over a plus c. We use this version when the domain, let me show the domain. Domain is between, the x is between negative 1 and 1. And negative 1 and 1 are not included here. And then negative 1 and inverse cotangent, the domain is x is smaller than negative 1 or no, x is smaller than negative 1. Should be. The domain is x should be smaller than negative 1 or x is greater than positive 1. Because inverse hyperbolic actually have a form, and this is 1 over 2 L1 parentheses. It doesn't have the absolute value inside, so be careful. So 1 over a L1 absolute value of, I remember, is 1 plus x over 1 minus x. So if the number is between that, you will not get a negative inside. So another one, inverse quotient is form is 1 over 2 L1 parentheses x plus 1 over x minus 1, and if x is between this, you will get a negative number inside. So the domain should be x is smaller than negative 1 or x is greater than 1. If x is negative 1 or x is equal to 1, like that, both of them, you will see the inside 0, so it's undefined. So be careful of the domain. So overall, if we going to use the inverse tanx, you get this u plus 1 over u inside, right? And then we're gonna substitute tangent x into it. Never mind, but let me just use the hyperbolic cotangent because this situation is more common than this, because the inputs are always gonna be, the outputs are always gonna be smaller than negative 1 or greater than 1. This domain is way smaller, so we want to use the higher one, just a domain, just a function we have more domain. And I'm not going to use this here because I don't like this. It's kind of hard to memorize, in my opinion. So over here, you just get, first you divide by the inside, negative 1 over root 2, and then I'm going to use the inverse hyperbolic cotangent. Cotangent of u is just our square root of tangent x. And then 1 over u is equal to square root of 1 over u, right? And now u is tangent x, and then 1 over tangent x is cotangent x. Overall, you get, I would like to write it more clearly. Maybe I should improve my writing skill. My writing skill is so good. And then divided by the inside constant, right? And then here you just get positive 1 over root 2 inverse tangent of the inside is just root tangent x minus root cotangent x over root 2 plus c. Oh, this is crazy, right? And here is the deal. Just another square root first. Since we know cotangent x is the inverse, not inverse, is the reciprocal of tangent x. So tangent x is always greater than cotangent x. So this minus this will give you a positive number. So it's always gonna be greater than 1. We're gonna use hyperbolic cotangent here. but just another domain. I would like to use hyperbolic cotangent or this. Sometimes I will use this, but let me just, I like this one more. So up to you. You can also use this. So another domain. So let me just put down the answers. Square root of tangent x. Let me erase this. Erase. Keep erasing. Over. I memorized this. Square root of tangent x is kinda long. -1/√2 times inverse hyperbolic cotangent of square root of tangent x plus square root of cotangent x divided by square root of 2. I don't have any space, so I put the result here, and then plus 1/√2 times inverse tangent of root tangent x minus root cotangent x over square root of 2 plus c, like that. And number 2, what about this? I think some of you have already figured out. Just use our trigonometric substitution. We let x is equal to tangent theta, dx is equal to secant square theta d theta, because the derivative of tangent theta is just secant square theta in our theta world, right? So over here you get square root of tangent x, tangent theta, not x, and then 1 plus tangent square theta, and then multiply by secant square theta d theta. So 1 plus tangent square theta, you just get secant square theta. So this and this, they are cancelled. So what about this? The integral of square root of tangent theta in our theta world. Let me just develop it. Yes, we already done this one. So this is just -1/√2 times inverse cotangent of square root of tangent. Let me just put it in our theta world first. Plus root cotangent theta divided by root 2 plus 1/√2 times inverse tangent of square root of tangent x minus square root of cotangent x divided by square root of 2. I like to put a plus c at the end. Just here, what's our theta? Theta, you will get theta is equal to, no need. Here still, x is equal to tangent theta, put x here, and then cotangent theta is just a reciprocal, right? 1/x is just equal to cotangent theta, like that. So over you get -1/2 times inverse hyperbolic cotangent of square root of tangent x, tangent theta is x plus, and then square root of 1/x. You can write it as 1 over square root of x, because square root of 1 is just 1, divided by square root of 2 plus 1/√2 times inverse tangent of square root of x minus 1 over square root of x over square root of 2. Wow, this is crazy. You see? And that's it. But this is not the only way to do this integral. I think you can let u is equal to root x and then keep doing it. But because we have 2 sessions of the integral, so we're gonna use the answers of the first one. You always gonna use the first part of the answers to answer the session 2 question. And here is my video, and bye.